Wafer specification. We will be using 2-inch silicon wafer. It will be a single-side polished silicon wafer with 100 orientation and 4 to 7 ohms resistivity. Cleaning of silicon wafer is done using RCA cleaning process. In previous videos, we have learned mask designing and mask writing process. In today's video, we will learn wafer patterning process. In wafer patterning process, we will transfer patterns from a hard mask to a substrate with the help of UV light exposure. Wafer patterning process consists of 3 steps. They are as follows: spinning, exposure, and development. Today's video session will be on optical lithography. Optical lithography is a process in which we transfer patterns from a hard mask plate to a substrate using UV radiation. Before starting with the process, let me first brief you about the steps involved in this process. So the first step is dehydration. Dehydration is the process in which we remove the moisture from substrate surface. This also improves the adhesion of resist which we are going to put on the top of surface. So let's start with this process. In this step, we will bake the sample at high temperature. Now I have set the hot plate at 90 degrees. We will bake the substrate for 10 minutes. The second step in optical lithography is photoresist coating. In this step, we will be coating the entire wafer with photoresist. So today we will be using S1813 as our photoresist. We will coat the entire wafer with S1813. For this, we will be using a spinner. So first we will place the wafer with the adapter. And then we go to our program and press vacuum. Then you have to check that the adapter has properly held the sample. There is no vacuum release. So now we will edit the recipe on the spinner. As you can see that it consists of 2 steps. Right now we are on step 1. This step 1 is called as spread step. This is basically used for spreading the photoresist on the entire wafer. And the second step is called as spin speed. This will basically define the thickness which you will require for your process. This will basically define the thickness of resist which you want on top of your wafer. For spin speed parameters, we can refer to corresponding data sheet that has thickness versus spin speed graph. For today's process, we will refer to S1800 series data sheet. We have used S1813 resist for our process, so we will refer to curve corresponding to S1813. For example, suppose you need a resist thickness of say 1.5 micrometer. You can set a spin speed value of 3000 RPM. So for PPR process, we set the time to 30 seconds and we will set the RPM 3000. This will give you a thickness of 1.5 micron of S1813 on your wafer. With this, we have cleaned the entire surface of silicon wafer with nitrogen gun. This was to remove any kind of dust particle that might have settled on top of the wafer. Now with the help of a dropper, we'll coat the entire wafer with S1813 resist. You should make sure that you are coating at least 80% of the wafer with the resist.
Then you can close the lid of the spinner and start the spinning process.
You can open the lid. Then you have to remove the vacuum. You can see that a thin uniform layer of resist is formed on the surface of the wafer. After spin coating, the photoresist is baked to dry off the solvents and to solidify the film. Soft bakes are commonly performed on hot plates in a temperature range of 90 to 110 degrees Celsius. So we will soft bake this sample at 90 degrees for 3 minutes.